top, and here the bottom. Here it's a lot, and down here it's only a little. And as a result, acid concentration is low, and here it's high. So at the end of the discharging process, you have an acid gradient. And it is important to remove this acid gradient. Why is that important? Let me give you an example. If 3 of the tires of the Volvo have the right tire pressure, and one doesn't, it's not really a safe car anymore. If this building, 3 of the outside walls would be strong and the 4th one is not strong, it's not a safe building anymore. And here this is the same. If you don't remove the acid gradient, you operate the system in a poor state. You have the level of aging, the speed of aging is different in different places. The voltages are different, the currents are different, everything is different. It's just it works. Doesn't work as a good system anymore. Okay, so you have to do something about that. And there are 2 ways of doing something about it. The one is you use AGM or gel batteries, which are the valve-regulated lead-acid battery or sealed lead-acid battery, that sort of thing. And what you do there is you prevent. Okay, you cannot prevent that this happens, but you can prevent sort of acid going this way and moving freely. You just make sure that the acid stays where it is. So when you charge, okay, all the acid that has been removed into the lead sulfide is reconverted, and it stays here at this point. And so at the end, you don't have any acid concentration, acid gradient anymore. That happens with AGM and gel. And the other alternative is, if this is here now your container, you put in a tube here with a small pump, and you blow air in. I mean,
blow air?
Yeah, just air. But just sort of like this.
Well,
yeah, just bubbles. This probably the smallest pump that you can buy in the world, will be sufficient to make sure that the acid shifts around and acid concentration is always the same. If you don't do that, your lifetime will also decrease dramatically. And of course you can change, you can do something else, you can do severe overcharging. When you do a severe overcharge, which isn't so good, explain this here, but if you do it once every 2 weeks or once in 4 weeks, then lots of bubbles of hydrogen and oxygen will appear, and they will also just move this around. Every forklift truck, well, not everyone, but most forklift trucks with batteries, at the end of charging, their voltage goes fairly high in order to recirculate the electrolyte and the wheel out. So you can pick it, you know, you can pick your selection, but you have to do something about that. If you don't, short lifetime. And the fourth one is, don't use starter batteries. Don't use starter batteries. A solar battery has perhaps here a thickness of between, I don't know, 3 and 6 millimeters, something like that. A starter battery, the equivalent thickness of plate is between 0.8 to perhaps 1.4 millimeters. The starter battery is geared for, you know, for high currents. It's geared for low low self-discharge. It's geared for a 5-year operation without anybody looking at it ever. It's geared for short periods of overcharging. A battery that is in your car for 5 years will be, I mean, how many operating hours does the car have in 5 years? 2,000 hours? That's equivalent to 3 months. Okay. So it's not geared against corrosion from high voltages either. So yes, you can use a starter battery for a photovoltaic, for a solar system, but basically, you know, sell your customer sort of a standing order for a new battery every 6 months or every 9 months.
But for the forklift truck, is it use this battery or the same battery for the solar?
Oh, this would be your battery just for your car that you have in your car, in your truck or so. But this is a specialized battery.
Yes. In the forklift truck, which one do you use?
They have
also
they have very similar systems like that. And in fact, if you cannot buy solar batteries because they're not available or because they are too expensive, then just use a forklift truck battery. It's probably not quite so good, but
still in function. Similar.
So for electric cars also we should have this battery.
This type of battery, not this one.
Not this one. How about the lithium-ion battery, the small battery just for camera, like just like say about this size? Is this also good?
Yeah. Lithium-ion batteries, they don't have this problem. No, sorry. They have a different. They don't have this problem. Lithium-ion batteries have a more severe problem here and there.
Sorry.
With if you have a battery with water as electrolyte, and then acid battery, nickel cadmium, nickel metal hydride. What you do is you connect these batteries in series, like this.
Yes.
Okay. However many you want, and you connect it to your load or your charger. It's beneficial if you supervise that system, but if you don't want to supervise it, don't supervise it. If you have, that's for PV batteries, nickel cadmium, and nickel metal hydrides, with water in the electrolyte. That is the important thing. If you do that with a lithium-ion battery, what you have to do is you have to supervise the voltage of every cell. Measure it. You have some sort of control unit. And feed that back to your charger or your load. Sometimes you have here a sort of small switch. So if that voltage gets too high, then you know some of the current gets bypassed here. You know, with batteries with aqueous electrolytes, just connect them up and that's it. With lithium-ion batteries, you connect them up, and then you really have to use a battery management system. I mean, there's no battery management system in the lithium-ion battery here. It's one cell. But as soon as you have two cells, there is something that they do. Sometimes they have internal safeguards, internal fuse that you don't see, internal resistor which, when the battery gets hot, cuts the electricity, something like that. But for batteries for lithium-ion batteries which have more power and more energy, I have not heard yet of anybody who seriously says it's possible to operate the system without such control. So, yeah, lithium-ion battery is smaller, it's lighter, it possibly has a longer lifetime. But here you go as far as the technology is concerned. And if you don't do that, have you seen in YouTube the pictures of the laptop where suddenly there's a fire coming out of it? You search YouTube for accidents, lithium-ion batteries, you find a nice selection of beautiful pictures of what happens. So, yeah, you can use them, but you must observe that the individual cell will be more expensive than your individual lead-acid battery, and then you have all this on top. So, yeah, I would stay away from lithium-ion batteries.
But Hopik now have a new prototype for lithium-ion battery. When we visit to Hopik, they saw that.
And they've told you about this?
Yes, there's data connection for each.
So we can
measurement
monitor
for
this battery directly
That's
from
right.
maybe this function for the controller also.
And have they? Did you go to Hopik
Yeah.
Pilon?
Yeah.
Ah, okay.
Yeah.
Yeah.
And did they give you a price comparison of?
No, the weight comparison and the capacity very
The weight
light.
comparison. The weight comparison is impressive, and the price comparison is impressive too. Yeah.
Okay, Professor Wenzl, I want to know more about the impact of the temperature, because actually in Indonesia, in Jakarta, it's quite warm.
Yes.
Yeah.
You please
Yeah.
maybe how does impact for the lifetime and also the
What to do?
Was heißt das? Arenisches Gesetz. Arrhenius. Arrhenius. Okay, chemists and what kind of training do you have? Are you an engineer or?
Oh no, my background is marketing.
Ah, okay. Okay, so you. Okay, this was a Swedish scientist who lived, I don't know, 200 years ago, and he showed experimentally that if that the speed of reaction of chemicals increases with or doubles if you increase the temperature by 10 degrees, and it as a general rule, it goes for everything. You know, 10 degrees more, and your speed of reaction doubles. So at 20 degrees, you have speed of reaction of 1. At 30 degrees, you have 2. At 40, you have 4.
Yeah.
At 50, you have 8. Okay. And that also goes for corrosion and all other aging processes. So your lifetime is here 1, here half, here quarter, and here 1/8. In fact, the American car battery industry, they've made a survey of how long starter batteries last in the individual states in the US, and they've mapped the average annual temperature. Wisconsin is cold and Texas is hot, with the average lifetime. And basically, this has been confirmed. Cold state, long battery lifetime. Hot state, no battery lifetime. So bad for your country. But of course, you can do something about it. You can put the battery somewhere where it's not quite so hot. Some years ago, somebody suggested he developed a product. It's called Coolbox. I think it's. Have you heard of it? I think it's an American company who developed that. It's
With this thermoelectric. Yeah.
No, I think it was passive.
Passive.
I don't know in detail. I thought it was passive, and the temperature inside, varied only a little during the day, because at night it's cold in your country as well, I presume, and so the average temperature remained fairly steady. Of course, you can't put a battery into a closed environment because the gas needs to be vented. But I think they had that as well. I think the product name was Coolbox, so that would be something. And I would bet a reasonably, not a high amount of money, but a little bit of money on the fact that the investment into such a cool box will pay itself by longer lifetime for a battery. Because yes, the temperature is important.
Is it maybe possible to bring them into the ground, make holes and
Sure.
things like this?
Dig a hole, dig a hole, put a plastic container in, put the batteries in, put a lid on top with some sort of insulation and one hole.
They do in Arabic, in Middle East maybe, they put the battery under the ground.
So that would be, very, very good. If you put the battery in the sun, you ought to also invest into a battery company, because you'll be selling.
Buying more.
You're selling more.
So, but not colder than 20 degrees or so. So 20 is optimum.
Level of temperature.
The performance goes down with temperature, but lifetime increases. The batteries in what you call cold storage places, where you keep frozen food when it's sort of minus 20 degrees, and they use battery operated electric forklift trucks, And these batteries have a lifetime of many, many, many years. 10 years, 12 years. Because despite using the battery and current going through, battery temperature is very low. But capacity is low and power that you can draw from the battery is also reduced. So you can't drive the forklift truck like a Formula One racing car. It's more like a small polo. Yeah, so temperature is important. Ventilation, of course, for safety reasons.
Circulation.
You've got to make sure that the ventilation is there. Protection against, people thinking that they should perhaps, connect the poles with a wire to see what short circuit power can be drawn from it. Don't make it easy for people to, to handle the system.
I have another question. This is maybe quite technical. If we want to compare these two batteries, for example, is there any special test to know the quality of this battery?
I don't think you can see the quality of the battery. I think you can only rely on the battery manufacturer. There's certainly one thing that you can do. If two people come and say, here's a 100 ampere hour lead-acid battery for the use of solar systems, we've done all our homework and this is a good battery. The one battery weighs 100 ampere hour battery, 6 volt, would weigh perhaps 20 kilos, or something like that. The one says, here is my battery, it weighs 20 kilos, and the next one comes and says, here's my battery, it weighs 24 kilos, same price, buy the one with 24 kilos. Because the kilos will be lead, and the more lead you put in, the safer you are. But otherwise, I think
Tips from Professor
many years ago I worked for a battery company and they produced very, very good quality. And then reports came in from the field that there were battery failures. And obviously when beginnings one thought, freak accident can happen. And then became a picture that batteries just didn't last as long as they used to. And customers were a little bit upset about that. And it then turned out that there was an alloy in the lead which was used, which was a little bit higher than it had been before. Nobody knew, nobody measured it, and suddenly you have a problem. So Hoppeck is a really high quality manufacturer. Did you see the production facility?
Yes.
Yeah. Okay. It's noisy. It's smelly. But you probably also saw that on certain points there are all sorts of electronic gadgets and measuring, supervising, etc. So they make a good product, but they rely on some sub-supplier selling them a certain component, and that sub-supplier relies on yet somebody else to sell them a certain component, and he changes that. He doesn't know that it makes a difference, and all of a sudden, here we go. So, the good quality now, the good quality in 4 or 5 years' time is, I think, the result, a little bit of luck, a little bit of constantly doing your homework and constantly making sure that you're trying to improve the process and make sure that they're all the same. see it, and you can't see it from the data sheet. There's no choice.
But do you have some experience, so maybe for some longer terms, to compare batteries, maybe cheap Chinese batteries or good quality batteries, and maybe compare also the price differences with for a new battery also?
No, I don't. Many years ago, I was asked to analyze the lifetime of batteries from different manufacturers. The customer wanted to know. I think he bought batteries from 3 different companies, and he wanted to know which one lasted longest. And the analysis didn't lead anywhere, because he used manufacturer 1 for one application, manufacturer 2 for another application, manufacturer 3 for yet another application. So different lifetime, yeah. So it means the applications are different, and it didn't give any information. Certainly, there are these battery council standards. People selling, sort of a 10-year battery or an 8-year battery. These are laboratory tests. Their relevance for your application is, well, limited, but has some relevance. It's like buying a car, and it will say this car will go 250 kilometers an hour. Now, for German motorways, that may be irrelevant information, because you can drive 250 kilometers an hour on certain stretches. But in Indonesia,
Traffic jam.
okay, so
Sure.
yeah, you have these, you have this data there. If it's a 10-year battery, you probably will have a longer lifetime if it's an 8-year battery, and possibly lifetime will be 25% longer as well. But I think nobody really will know, and nobody will really be able to, to tell you. And I think you will also not get any guarantees for batteries. No real guarantees for batteries. Okay, yeah, 4 years, yes, but.
Good question, without guarantee. How big it gives 4 years warranty?
Probably on a what's called pro rata basis.
Yeah.
If the battery fails after 2 years, they will say, right, we will sell you the next battery for 50% of the original price, which is some kind of a warranty, but very limited. It may be cheaper for you to buy it because somewhere else.
Professor, I have one question. How could we can charge the battery very fast or faster? What is the possibility for fast charge?
I think you can charge most batteries within 1 hour without a problem. With lead acid batteries as well.
1 hour for
Yeah.
full charge from the empty.
Yeah. I mean, if you look at your car, the generator has something like 1 kilowatt electrical output. Your battery has, 60 ampere hours. So if you drive your car and the generator produces 1 kilowatt, no lights, not anything else in terms of other electrical consumers, and 1 kilowatt divided by 60 ampere hour means, divided by 12 volt means that you have 80 amperes charging current for a battery.
There is no problem with the overcharging or